this integration has been deployed on CommScope network. So the server with Oracle Unified Assurance application is deployed on CommScope network, and therefore it can communicate to the imVision server that manages imVision installation in our CommScope's office in Madrid. And as part of this segment, we prepared several live demos of the use cases to show how the both imVision and Unified Assurance interact. Okay. So the main feature of this integration is ability to provide unified view of the network, and which provides real-time visibility of end-to-end connectivity to NOC teams. Okay, so they can be much more efficient in understanding what's going on in the network, right? Plus, it enhances monitoring capabilities because it eliminates the blind spot associated with information that comes from physical connectivity layer of the network infrastructure. Additionally, information from imVision related to number and status of connecting points, physical connecting points, number and status of a type of segments, whether it's a cabling segment, whether it's a patching segment, also location of connecting nodes, right? The location is very critical part of network monitoring. And finally, the system can provide you information about cable type and even cable test results that may help you in investigating the potential performance issue, right? All of that is providing expanded insights into the structured cabling and the network infrastructure to NOC teams. Okay, and now we're going to move to the first live demo. So I'm going to switch to my screen, and here you can see the live view of imVision database. And just quickly to walk you through what you see, this is on the left-hand side, you see the site tree that contains different locations within the CommScope network. And the Madrid office is the abbreviation for the Madrid office ESMD1. Okay, and here we have a data center. That's our production data center that manages this office. It consists of 3 racks, and each rack has a number of different devices mounted there. And each device, if you select individual devices, it will show you the ports that are presented on this device. So, for example, if I select the router, it shows 3 ports. 2 of them are connected, and they support live traffic, as you can tell by green dots, green icons to the left of the port icons. Okay. I also will show you example of various types of circuits that you can monitor in imVision. So this is an example of typical circuit in the office environment, where you have a switch on the left-hand side, which is cabled to the intelligent patch panel. This intelligent patch panel is then patched to another patch panel that's cabled to the consolidation point. Consolidation point is cabled to the faceplate, and then the faceplate is connecting to an end device with a specific IP address, which shows also that it's been live since this morning. Okay, so this is a typical circuit trace for the office environment. And for the data center environment, as I showed you before, I'll select the router port G001 to represent the typical data center circuit, where you have a router, which is patched to an intelligent panel, which is cabled to the specific switch. And this is the managed switch, as you can see through the lightning bolt. So it's monitored through SNMP. And that's the time point for the integration with UA, because the same device is also discovered by UA which makes the integration more natural because we're talking same language, right? We know exactly the IP address of this device because it was automatically discovered through SNMP. We know the name of this device, so it makes it much easier for us to make connection. Okay, so now I'm going to turn it over to Jason, and he's going to walk you through how this integration is represented in Unified Assurance.
Perfect. Thanks, Michael. Yeah, so like Michael said, this is where we are able to make this integration with imVision and pull in all of that hardware data into the Unified Assurance topology. So if I start with that same device that Michael was looking at, and we select it here in our topology, this is just kind of an ad hoc, build it as a one-time, can always save it. But I'm just going to go out 2 hops from that device, make sure I'm showing all of my interfaces, and you can get populated down here in our graph. And so we've got that same router and the 2 ports that Michael showed us. And if we look at port 001, it goes out to a port 121. Well, we only did 4 hops, but we can do a quick right-click tool and say, show me a couple more hops, right? And we can start to see as this device pops out more interfaces, we can go up to port 73 and do the same thing. And this is where we can start to see some of those panels, right? And so on port 73, we can see some panels. On port 121, we can see some panels. And we can quickly say, okay, let's see what's connected to that 10 gigabit port. And we can say next hop. And we can start to see now, same device that Michael was talking about. And this device, because we have active monitoring, ping, SNMP, trap, all those sorts of things connected to this device, we now can see a live feed of this device. It is up, we're able to ping it, but there are some issues going on with it, and we could do a right click and say, show me the current events going on this system. And we could go into the event list. We could take a look at what was happening, all those sorts of things, because we've normalized all this data across, right? And seeing this, right, this might be a little bit crowded. There's always the ability to change the layout. You can go to a concentric view so you can see kind of a layout that way. There's all different types of views, and these layouts are customizable as well. You know, I tend to like the hierarchy so I can see where I started from and what's connected to what and where I go from there. The other thing to note when we're looking at this, and this is kind of hidden off to the side because I wanted to show a little bit more of the graph, but now if I click on this core switch, we can see some information over here on the right. And if I expand this out, this is all information we can pull from any source and we can store this data. So if we look at something that we specifically received from imVision, there's different information about the ports, right? We've got all this information that we received from imVision. We can start to use this data to do correlation enrichment so that when an issue happens on core switch 01, we can route that back to the 10 gigabit Ethernet port, and we'll probably have a lot more information than we would have just from SNMP because we have this integration into imVision. And that as well goes for the links between devices. All of these edges, they're called in our graph database, can have as much information as we know about from imVision as we want, or from another tool, right? That is where UA, being open and able to connect to many other tools, we see there's a circuit segment. We can start to use this ID if we know what customers are attached to that circuit segment, start correlating and enriching alarms, so that that customer may be affected. So this integration can go as wide and as deep as you would like for that information. We'll give it back to Mike so we can show you guys the next use case.
Thank you, Jason. Moving on to the next use case, we're going to talk about the accelerated incident resolution, right? So, for example, in current UA, you can see that all of a sudden one of the devices is no longer communicating on the network, right? And you're facing the need to do the investigation to figure out what caused it, right? By adding imVision information and specifically real-time notifications related to connectivity changes, you can correlate the, let's say, unplanned connectivity change to the incident related to the device no longer communicating on the network, right? And it speeds up time to investigate the incident and to identify the root cause of the incident, right? Greatly reducing mean time to restore this device connectivity on the network. So to demonstrate this particular use case, I'm going to ask my colleague Max Healer, who is based in Madrid, to just disconnect the patch cord, and then we'll switch to the UA view to show how this particular event will be shown in the UA. Jason, it's all yours.
Yep. We'll go over to our event list here. We'll take a look at all events. So these are all the events that we're seeing currently in Vision's network. Second. But just showing you guys a bunch of the different alarms that we've got in the system. And see all the way down here, we have an unscheduled connection alarm that came just now. And we can see all the information in here that is available to us to do enrichment, to do correlation against, right? All of this data here that imVision provides with their trap can be parsed out, can be set into specific fields, can help us filter these alarms in specific ways. We can start to do automation, right? We can do automatic testing and make sure that, you know, if we see this scheduled connection, does this port, is this port a part of a redundant setup? Are there redundant links so that this one being unplugged doesn't mean we're down, but like I talked about earlier, we can degrade the service because there has become only one route is available, and we can go make sure that that route is still up so that the service is not completely impacted. The other thing to note in here is we do have a details field where we store the entire trap. So everything that's come across is always available to a user to see what the full details, whether that depends on what we all pulled out of the trap itself. And so all of this data can be parsed into any of the alarm fields that we provide out of the box. We also provide you with the ability to add any fields that make sense for your environment as well. If the out of the box do not cover all of the use cases that you might have for your faults in your embeds. And again, so the whole goal of this is just anytime something happens on the network, when imVision sends us a trap like this, there's a lot more information that we can then use to topological root cause or correlation or anything like that. We want to do the next use case there, Mike?
Sure. So the next use case is performance management, and through UA you can certainly monitor the bandwidth and the throughput on switch ports and see if there are some bottlenecks or some degradation in performance is happening. And with the integration between UA and imVision hardware, UA has ability now to identify specific connection nodes, like panel ports, that need to be examined to see if maybe the physical connection at that port that may be causing the degradation. Like, for example, somebody was working in a rack and accidentally kinked the patch cord that was connecting to a specific port. So by having full visibility on the entire circuit for that particular switch port, the NOC team can light port LEDs on the panels that are part of the circuit and guide technician to check the connecting patch cords on each of the ports to ensure that if there is a kink, they can certainly address it and make sure that the performance degradation has been resolved just due to this accidental, I guess, kinking of the patch cord. So you can see on this slide that this LED port was lit up through the UA.
Yeah, and just to expand on that, so with the ability for imVision to have a fully documented and robust API, Unified Assurance is able to use what we call our custom action policy engine for when we see an alarm that is bandwidth utilization tracking too high, it's trending high, any number of thresholds or alarms that are concerned, we can go into the API and say, we know what port it is, we know what rack it is, we know all this information because we're fully connected into imVision and we have all of that. We can use their API to immediately guide an engineer to a specific location within the rack of where Unified Assurance believes that there is an issue occurring, whether it's bandwidth or any other, maybe someone jostled a port and it came loose. We can alert that, hey, there's a disconnect here that you may need to take a physical look at.
Okay. So the next use case is, well, we all know what location means for real estate, right? But it's critical for the network infrastructure as well, especially when you're troubleshooting the specific network incident, right, that requires physical access to the device, right? So imVision provides location information for the devices where they are in the office environment. It will tell you which room they are in, which outlet they connect to, or if it's in the data center, it will tell you exactly which rack they're in and location of the device in that rack. So this way you can quickly focus on getting to the device to resolve whatever the issue could be. And it could be, for example, maybe a swappable SFP module is malfunctioning, so it needs to be replaced. Or it could be security-related issue. Through your NAC, you saw that the is unauthorized device is trying to connect to the network. So through this integration, you'll be able to see location where that unauthorized device is trying to access the network, and then you can send security team to see who is the person who's trying to gain access to the network. So location is by far very important element of the integration because it gives you additional information that without this integration, probably the NOC team would not have. And the last use case is enhanced service assurance. So I'll turn it over to you, Jason.
Yeah, thanks, Mike. So, the goal here was around when a user puts in a work order for something in imVision, changing a port, changing a circuit, any number of things they put in a work order. And when that work order gets created, a trap is sent into Unified Assurance. Goal is we can start to take those traps and we can confirm what the goal of that change is going to be, whether that's going to cause an issue or whether that's that trap, that change makes sense. Using that custom action policy engine I talked about, right? We can validate those changes, and then if nothing seems wrong with the work order, nothing changes, the work order gets executed when it's scheduled for, and UA can, again, then when that execution happens, get the alarm that occurred, and we can go out and we can test. We can make sure that the change has done what it meant to do, and there are no degradations across the circuits. There's no wrong routing happening, anything like that, because our custom action policy engine is just an open correlation enrichment piece of Perl that it's written in, and you can just go in and build those sorts of things. And so we worked on some of that with the imVision team.
So, and to demonstrate how it works, right, we're going to work with the same circuit, with same devices that we already familiar with, and it's the router 01. And what we're going to do is we're going to create a work order to disconnect the router from the network. Okay, and this is the patching feature in imVision that allows you to quickly schedule the work order. Okay, and the work order is given its unique ID. We're going to set the high priority for that work order and schedule it to be done immediately. And okay, so the work order has been scheduled. And Jason, if you can walk us through what happens on UA end.
Yep. So if we come back in, we can do a quick refresh on the alarm list because it's paused since I was investigating things. We can always sort by any number of the fields when we'd like to. So we can go to sort by first occurred. And we can see right here, we've got this work order patching that came in from imVision. We have a whole bunch of summary. This summary can be custom, it can be dynamic based on what we're working with. But at the end of the day, again, like we talked about with the other one, we have all of the information here that imVision is providing us. We parse through it. We separate out the important information that makes sense and is useful. But again, once we've got that topology, we understand where it's at in the network, what it's connected to, and we run all of those tests in our custom action policy engine to confirm that the network's going to be okay, that there are going to be no outages, and that the goal of the work order is going to be successful.